Okay, so good evening, class, once again. This is week 7, and last week we didn't really study anything like a new concept technically. We just saw a lot of questions that we could solve using the existing knowledge we had so far. So, once again, if you have any queries regarding the previous week, feel free to ask. I'll try my best to answer. And since you are technically halfway through the course, I wanted to just put a Google form where you can put any queries and suggestions for me to improve my way of explaining things to you. So if you scan the QR code above, you should be able to get the Google form. So I hope the QR code is scannable, because maybe because of the compression of Google Meet, it might not be good enough. So could someone check? Like, uh, hopefully it will work. Okay. Anyways, give me a second to. Yeah. Okay. So for today's class, I feel like the first thing we have to do, we can do is like just similar to how we did random questions for the week. We'll do we try to make a complete project in Python. We'll try to make the game of Connect 4 in Python, and I hope all of you know the game of Connect 4, because okay, just to make things obvious, we'll first go through the game of Connect 4. In the game of Connect 4, there'll be a board which is of size 7:6, and at every it's a two-player game. Generally, there's a red player and yellow player, but for our presentation, we won't be using those colors. We could, that's up to you, but we'll do it later. Uh, so at every step of the when it's the first player's turn, they'll drop one chip down. There'll be multiple of these chips in the game, and they will keep putting these chips from the top. So the objective of the game is to connect 4. This is honestly an awful game of Connect 4, because somehow both of them have won, but that's irrelevant. Like, this is a more normal game. So the objective will be to code the game of Connect 4. So the first thing we can do is to just do it within the terminal itself. That is, instead of having an elaborate window and showing it outside, we can first try to play the game of Connect 4 within the terminal itself. So naturally, the first thing to do is to visualize the things. So there are two important things in game of Connect 4. Or, I mean, there are many important things, but one important thing is the board itself. So we'll first do that, code that. Uh, as you see here, the board is essentially an array of 7 into 6, a two-dimensional array. In last week's class, should have come across other two-dimensional arrays. So, and that's why I felt like this should be a natural thing to start. So let's do that. So we'll call it board is equal to, it's a two-dimensional array. So we'll just quickly fill it in. I will fill it in with list comprehension, because I feel that's the most intuitive one. And because we'll want to print the board at every turn, it will be very useful to have a function to print. So just to make sure this looks right, we'll just yeah. So we have 7 rows, 7 columns, and 6. I can't count. And 6 rows, which is just what we want. Okay. So to the people who came new, I should copy this into. Yes, Varadraj, do you have a question?
Sir, is it possible there could be little more of an explanation for those who missed the last week
Could
live
you,
session?
the last part of what you said, I was not able to hear it properly. Could you repeat that?
Sir, I missed the last week live session, and
Okay.
so the progress which has been made with regards to the course is not, I'm not up to speed. So a little more explanation if that's possible.
Okay,
Just,
I can quickly go through what we did last week. Give me
sure.
yeah, so last
Thank you.
week,
Thank you.
yeah, sure. The most important thing we did last week is the concept of recursive functions. What's this? Oh, yeah. Anyway, so the concept of recursive functions is basically like a recursive function is a function that is likely to call itself. That is, for example, consider the mathematical definition of a factorial. Okay, a factorial is, so if I take if I want to find the factorial of 5, I have to multiply 5 times 4 times 3 times 2 times 1, which is like a lot of multiplications, but it's understandable, it's reasonable. Now, you can do this using loops. You can have a for loop and then multiply each of the terms via a loop. Uh, The reason we use recursive functions, it will be more obvious for more difficult questions. So, but it's necessary to kind of we can first solve this using factorial before we go to the more difficult questions, right? So the interesting thing about this is, if you are going to do factorial of 4 instead, you can see by logically factorial of 4 will be this, right? I should put my camera here. Yeah, so okay, that's worse. Never mind. Okay, okay. Anyway, so my point is, the factorial of 5 contains the factorial of 4. So instead of calculating factorial of 5 like this, we can calculate factorial of 5 by replacing this section with factorial of 4. So this is what I mean by a recursive function. The function calls itself. So this is very similar to the mathematical definition of an inductive proof. That is a proof which is like step by step and things like that. So in an inductive proof, we have two things: the base case and the inductive step. Likewise, a recursive function has two parts: the base case and the recursive step. So you can see how this factorial function is essentially the same thing as this. This is exactly what I've done here. The factorial of n is n multiplied with the factorial of the previous value. And I have also given a base case, that is, say there's only one place where this breaks. The factorial of 1 is 1, and the factorial of 1 is 1, and it's not the, if you ignore higher maths, we can say that the factorial of 0 does not make sense, so we can just leave it at that, right? So the first case is, what is the factorial of 1? Every other number can be defined in terms of the factorial of 1, and that is why this is the recursive definition of factorial. But the thing is, factorials can be so much more interesting. You can have factorials like this, and if you I highly recommend last week's lecture, because this has a very unintuitive solution, and the actual answer you'll get in the end is very trivial. So and things like that. So essentially last week we mainly went through factorials. Yeah, all of these are essentially questions on factorial. But that's mainly because that's the coolest topic last week. So I know that's a very quick overview, but if you want to do questions on factorial, you have to solve it yourself. And like the lectures are there online, so you like feel free to watch the lectures and pause the video, solve it yourself, and things like that. Additionally, I'll have like extra questions on the top of me here. I'll have extra questions on the top of me here, which I have not noted down. So if you want to solve those questions, you can solve them also. And okay, so to those of you who have come in the last few minutes, I've also put a QR code above. That QR code is not official or anything. It's just for me to improve my teaching to you guys. So if you want to answer, feel free to answer. I mean, please do like fill the form and things like that. It will help me a lot be a better teacher. I can save this. And yeah, this is so for today's class. We'll try to spend most of the class on the Connect 4 aspect, and then if we have extra time, I want to try this Python and the web, because why not? It's a nice topic, and I feel it kind of ties in well with next week's lectures, so it might be interesting to you. So I hope the things I've done so far make sense. I have just printed the board. Now, to properly play, we need two players in the game of Connect 4. So we'll have okay, we'll just have the names. Player 1 name is equal to and likewise player 2 name. Now, to make the game look decent, we'll have will not have anything in the board if there's nothing there, and if the player puts something, then it will uh, then there'll be something on the board. So we'll just say that player's 1 symbol will be an X and player's 2 symbol will be an O. Player 1 symbol equal to X and player 2 symbol equal to O. So we'll just do while true. Last week's lectures did point you in the direction of how to use while true and things like that, and we'll essentially be doing the same thing. Vardharaj, I hope I clarified what we have done last week, and is
Yes, sir.
yeah,
Yes, sir.
yeah,
Thank you
and
so much.
yeah, no issues. Okay, so okay, so we also need a counter for the turns. Counter is equal to 0. Okay. So if it's player 1's turn, the counter will be even. If it's player's 2 turn, the counter will be odd, because yeah. If counter mod 2 is equal to 0, then player 1 turn, and we must get an input from player 1 asking in which column he wants to put his piece. So we'll get that. Call is equal to int input, which column do you want to put the piece. If he doesn't give an integer, it will give a wrong output, and that's fine. So we'll just quickly do things like, if okay, let's just assume that the players are good people and they're not going to give us bad inputs. For example, they won't give give an input like 2.5, which could potentially break the code, but that's not the fun part of programming. So the column is, we have a column, and because of gravity, the piece will go from the top all the way to the bottom, and it will, if there are pieces below it, it will just stay there, right? So as in, if so if there's a piece here already, then the piece will land here. If there's a piece here and here, the piece will land here. If there's no piece anywhere there, the piece will land here. So we'd want to place the pieces accordingly, right? So we'll do that by with a loop or a while. Okay, then it doesn't matter. So the board is I comma j. So hopefully this will give us okay, that's correct. That's so whenever I personally write code, I always make sure the results make sense before I carry on, because otherwise things can go wrong. Like if I write the entire code and then I find I realize there's a mistake somewhere, then there's a lot of things I must do to figure out where the mistake is. So in general, when I write code, I try to uh, make it like step by step. So I'm putting this break here so that the code does not just keep going running. I just want to work out, right? Because I will forget this eventually, I'm just putting the increment here. So if I is equal to okay, give me a second. Okay, so now we have tried to put I all the way at the bottom. There's just one small edge case which we'll worry about later, but we'll finish the main part essentially. So now we know the location of the piece has to be call comma I. So we'll just set that. Sorry, board of call comma I is equal to player one symbol. I'm putting a slash t so that all of them will be well aligned. And after this step, I will print the board again. Print board. It doesn't matter that I've not coded the player 2's levels things yet, but that's fine. We can do that with a copy paste. We'll just run this quickly and hope things work. What is player 1's name? Man. I'll put it in 1. So I did make a very stupid mistake, and that is everything's vertical instead of horizontal. So I have to fix that. This requires me to draw things out. So I'll just open paint and code. So Okay. So by the way, because it's a Python code, the indices start from 0. So I'd want, we can essentially order this however we want. This can be 0 comma 0, this can be 0 comma 1, and so on. But if that's the case, then so this will be, so it will be row comma column, and as the top row will be zeros and the bottom row will be 7. So that means this is fine, this is fine, this is not fine. Or row, even this is not fine. I am going through the rows in reverse order because I must first, oh, this is right. Okay, it's convenient. This is so, I am so sorry. One, two, three, four, five, six. Yes, 5. Oh yeah, it's row comma column. So that's the mistake I had made. I'm so sorry. I comma. Okay, now it should work. Oh yeah, because we are zero indicing it, the first column is 0 and so on. We can quickly change that also. And now if you're doing it again, 1 comma 1, the first column, let's put it in the first column, then we're placing the first column. We need a flag. Oh god, I am really sorry. So okay, I'm going to change this again. Give me a sec. Okay, we'll write out all the conditions explicitly. There is, if you are putting the thing inside the column, there are three cases. Firstly, the column is empty. We can check that at the end. Thirdly, the column is already filled. If the column is already filled, we'll consider the case later, but we'll now write it down. If board of phi comma column is not equal to slash t, pass. That column is full. Otherwise, with a while loop, we can go with with a while loop, we can go through the elements of that. The top one is this. Okay. With the while loop, we can go through the elements of the thing. So since I is while now no, instead we can check if the board is empty now. If board of phi comma call is equal to slash t, that means that column is empty. So I is equal to phi. Else, while I is if board of I comma call is not equal to slash t, okay, so it might have looked like I overcomplicated it, but this is the most logical way I can do it without making mistakes essentially. Yes, -1. Didn't increment it. Oh my god. It finally works. The placing the coins finally work as expected. And if we just keep doing it, it tells the column is full, which is as expected. Now we need the same capacity for player 2. So instead of doing that again, I can just convert this to a function and input player 1 or player 2 depending on the counter, right? So I'll make a function def player turn, and it takes player name and player symbol. I take it and I paste it. Player turn of player name, player 1 name, comma player 1 symbol. Else Control C, Control V. So here you can like essentially properly see why functions are so helpful. I had only done everything for player 1, but now I have got with very less effort, I've solved everything for player 2 as well. So we can save this and run. Player 1 name is 1, player 2 name is this thing. So you can see how the game is properly, kind of properly played, right? So if I want to place, it's player 2's turn, player 2's turn, and I'm placing it in the third column, and it places it there. It's player 1's turn now. I can place it in the third column also, and it places it there. I hope this was not too complicated. I know I made a couple of mistakes along the way, but I hope the steps made sense. The most complicated problem about this was essentially finding what to do if there are multiple uh, options here. Essentially, while I did think that there are 3 main cases in the beginning, I didn't want to say it out loud because I was scared it would be too complicated. But as you saw, not because I didn't mention the 3 cases out, I made a couple of mistakes along the way, and which is completely avoidable. But in the end, if you are coding, you have to write out every case. Did the steps make sense? So just as a small reminder, if you're not interested in, if you know what to do here and things like that, feel free to do the questions I've written up above here. Those are more fun questions in my opinion, and you can uh, write the answer and send it in the chat if you're done. And I also want to be like a better teacher. So if you have any suggestions on how we can improve, you can scan that QR code to get a Google form and fill in whatever you want. So there's that. Now, obviously, this thing can be a lot, we can change it a lot more. In fact, the player 1 and player 2 symbols can be customized and so on. But now we need a way to identify when a player wins, right? So we'll add that in the player turn itself. So def player win. Okay, so the main, oh, permission. Give me a second. What this? This thing should be available to everyone. Give me a second. Control Shift 10. I think Google just wants you to use, like, sign in to Google whenever you have to open Google Forms, it seems, because I'm not even collecting the email addresses. Uh, like, okay, I'm sorry. I had. Could you try once again? Yeah, I am. I should have. Yeah, thank you. So thank you for informing me. I didn't realize there was a small option I had to tick in because I'm logged into my work email. And anyways, so to check if a player wins, the easiest way to do it, like, you could check the entire board and see if there's any consecutive plus fours in vertically, horizontally, and diagonally. But that's a lot of work. The easier thing to do is to, well, check only the position where the latest piece has landed. That is, so say the player has put a piece here. If a player has put a piece here, then I only have to check these a few cases. Like, I don't have to check the entire board. I just have to check these four, and so on. So now it's just the elaborate way of coding it out. So I get the player symbol and column and row. and I have to consider the three cases. There's vertical, horizontal, and the two diagonals. So that's four cases. So case one, vertical. Vertical is the easiest one to check. The only way you can get vertical is if you put it here or here or here, and we have something like this, because it's not possible to put one here, right? So vertical is the easiest to check. We'll write that one, well, that case first. So if column is greater than 3, that's less than greater than 3, I'm so bad at maths. Okay. Board of row will be the same, column is equal to board row column row minus 1, it's row plus 1, column Now, as I said before, it's always good to check after you write some code like this. So we'll try that. Okay. So we're checking if it works in rows and columns. So I once again has forgotten subtraction. The if I is 1, if row is 5, it's minus 1. 1, 2. Which column do you want to put? 1, 2, 1, 2, 1, 2, 1. Well, the game didn't end. That means I've made a mistake. Lovely. I is 2. This is a disaster. I was right. 1, 2, 1, 2, 1. The row number should be less than equal to 4. No, less than equal to 2. If it's 2, 2 plus 3 is 5. 5 is inside. That's a mistake I made. Okay. 1, 2, 1, 2, 1, 2, 1, 2, 1. Yeah, so as you see, eventually it comes that player 2 1, which is as we expect. Yeah, naturally, this is not the optimum way to do it, but I've got something at least. Anyways, so now we'll go to case 2. When you go horizontal, essentially there's a couple of cases you must consider. It can either it can go towards the left, right, and both. So we'll include all the all. Oh my, there will be a bunch of cases, but instead of considering the cases like that, it's better. In fact, it'll be better if I wrote this in terms of a in a loop essentially, which will be of the form for I in range 1 to 4. If plus I not equal to, why is everything a mistake? I am not changing this. I'm okay. Okay. For case 2, horizontal, we have a couple of possibilities. Now, the column, we have to check things from, okay, the column numbers are from 0 to 6, and this number is between that. So if the number here is 2, if the number here is 1, then I don't have to check 6 and 7. I just have to check till 5. So we'll do it in this way. I will start from the, I'll start from here. No, if the column is this, I'll start 4 steps from the column. If the 4 steps from the column is towards the left here, then I'll just start from this point. If this is a different color, then I'll ignore it and I'll go towards the right until I see something of the same color. Okay, essentially I'll write it out and then maybe it will make more sense. Row check is equal to min of column minus 3 and 0. Dot. If it has not yet started, that means I should, else we know start is true. So maybe this will work. That was a disaster. Right. Dot. If it's true, that means it has started the chain. If it's false, I should only do something if this chain has been started. So if start is false, I don't have to do anything. Start becomes true if board row check is equal to player symbol. Makes sense. So once I'll print start. What counter is for? Oh, yeah, yeah. The counter should start with 1. Okay, got it. Now it will work. Players 1 name is 1, players 2 name is 1. Which column do I want the piece? I put 1, 1, 2, 2, 3, 3, and player 2 has 1, which is as expected, finally. So, and in a unfortunately similar way, we have to do something for the diagonals. So, yes, 1 equal diagonals. Fortunately, for diagonals, the code for this is not much different. So we can just change. Check is max of column. Okay, for simplicities, okay, that it won't work. We need the diagonals for a game of Connect 4. It's hurting my brain. Okay, row check, max of column minus. This is fine. But now, if I'm not checking row check, and I need to include column check also. It's not nice. Okay, we have to look at the diagram again. So, for the diagonal 1, in my opinion, should be this diagonal. So, if you are looking at this diagonal, note that the value of the I comma j can be anything from values here to here, and that's like and that's the entirety of the board practically. Now, if you say the piece is here, that means the first piece I have to check is this, and the last piece I have to check is this. So, and things are slightly more complicated because here I'm not going towards the end in this direction. I'm reaching the end in this direction. At the same time, for certain pieces, I'll be reaching the end in this direction. Therefore, we have the one way is to consider all possible cases, but that's too difficult in my opinion. It's I'll need a pen and paper to properly write it out. So instead of that, for this question, I believe the easiest way is to have a counter, and with that counter is I, which will start from -3 and go till +3. So I is equal to -3. However, if we are here, we don't have to check -3. We just have to check -1 away. So this is because the column is close towards to the end. So we can edit that by saying I is equal to max of column. Okay, in here column minus column is 2, column is 1, 1 minus, oh yeah, yeah, okay. And likewise, if you're here, then because the row count is less, we must the I will be different like that. So control C minus of row. This time I will the maximum value I can take is plus 3. So if not start, and hopefully that will work. I also need to make sure I does not cross the two boundaries. So if row plus I is greater than number of rows is 6, so it's great. If row plus I is equal to 6, then I break. If column plus I is equal to 7, then I break. That's a little ugly, but should work. 1, 2. This is also more difficult to debug, unfortunately. So I'm checking for this column, so I might as well put 1, 2, 3, 1, 2, 1. Okay. It didn't work. Lovely. 1 2. God. So here I is -1. No, why is I 2? No, no, this I is 0, true, and 1. So, oh God. Yeah, I fixed it. Now it works. One, two. As you see, it finally works. So, while the steps did not make that much sense, in the end, the only way we can code this properly is, well, with practice and stuff like that. As you see, so it would have gone a lot smoother if I had actually written down all the steps and things like that, but I didn't expect it to be this complicated in logic. And now we do the same thing for the other diagonal. Fortunately, the other diagonal, it's practically the same code. So in the case of the other diagonal, it goes like that. So -3. Here I'm doing row of -3. That's row of +3. So, okay, yeah, it's like this. So this, in this case, that's because of the column. Yeah, anything in this column will not have the that thing. So this is column 2. Yeah, it should be max of column 2 and this thing. This breaks because the row is 1. No, this. So when the row is 6, if the row is if the row is 5, then I if the row is 4, then I has to start with -1. So it's max of it's min of so here, yeah, if I start here, the row is 5. If the row is 5, the value of I should be 0. So will just be 5 minus row. If the row is 4, the I should be -1. Okay, so that's it. Then even these will change. So I think because we're going in that direction, row plus 1 equal to 6. That won't affect. It should be row plus I is equal to 0. Then it breaks. Okay. One, two. So I want this. Oh my god, this is so much work. What did I put? I put 6. Oh, lovely. If board of I minus 1 is got it. The value of I is 2. That does not make sense. Value of I should be -2. Oh. Oh, that was a mistake. Okay. Which column do you want to put the piece? And the code works. The code actually works. But because we have written all possible cases, the code that we kind of have guarantees that the code is always going to work. So that is there. So essentially, we have the code is pretty big and ugly, but it's something which will reasonably work at all times. I'm sorry this class went in a completely different direction, and I know all of you are just tired of looking at Connect 4, and all of this work. My objective of today's class was essentially to code this in like 1 hour and then do it using what is called Turtle. Like we can draw the board using Turtle and paint the colors using Turtle. Like you can have, so, but I leave that part of the thing to you. All the code will be there in GitHub, so you can look at my code, make changes if necessary, and things like that. Essentially, the only part you have, because of the way this is coded, it's modular in the sense the only part you have to change to include Turtle is the print board section. If I just change the print board, I can the program logic remains the same, but I can just take this print board and replace it with the Turtle version, and it will work perfectly fine. So that's another reason why it's always recommended that you work with functions, because if you're using functions, you can all your parts are going to be very modular, and that makes things a lot easier. Now, I once again must apologize because this took much longer than I expected. I forgot that the player win condition for Connect 4 is so complicated. There are so many cases, and I should have in retrospect coded this myself earlier so that makes it more obvious. But if there are any questions regarding what I've done so far, please feel free to ask. It's not It is a little complicated, I must accept. I and equal diagonals, other diagonal. So are there if there are no questions regarding this, I mean there's always a possibility that there always the possibility make this thing is a little too complicated, but in the end you should write down the code yourself. Has anyone tried the few questions I've written above? like I feel like the fourth question will be kind of fun and it's not too difficult. Okay, fun club. Anyway, so why is okay? It's saved. Like the other thing I wanted to try today for in today's class was to try Python with the web, because last week's class required one thing which involved a pip install. So I thought, why not include another thing for a pip install, because it's a pretty interesting thing. So because Python's a programming language, so in it you can kind of do most of the things that you want to automate using Python. And one of the things you want to automate might be like to browse the net and things like that. In fact, in like data science, which uses Python often, we do something called web scraping using Python. That is, you web scraping is essentially opening a website and downloading all information from it. So you can kind of easily do web scraping with Python. So for example, and okay, the in general you do web scraping with Python using something called Selenium. So you can do conda search Selenium, and conda will tell you if Selenium is available and on, and apparently Selenium is. So you have all these versions of Selenium for all the other all these versions of Selenium available. So you just have to do conda install Selenium, and conda will check. But because I already have Selenium installed, nothing is going to happen. Yeah. So if you want to follow along, I would recommend you conda install Selenium. If there are any issues, if you have any difficulties in doing that, feel free to ask in the chat. So I'll just open Python and we'll see. So the you might also not know what to do and how to do it, and because of, the thing is, all of these things have excellent documentation. So if you Google Selenium Python, essentially Selenium is not just in Python. Selenium is in most languages. So if you search Selenium Python, if you click the first link, it directly tells you how to get started. So yeah, so if you run this code, it will properly tell you how each of the things happen. So I'll from Selenium import WebDriver. Note that some of these commands will only work if you have the browser installed. So if I do driver.webdriver with Firefox, it will only work if I have Firefox installed. So when I run this, it has opened Firefox, and it's a slightly different kind of Firefox, because uh, when uh, when Selenium does it, the Firefox it opens is an automated Firefox. So instead of having the normal icons here and all, you have completely different things. For example, like your browser, your what the browser plugins will not be available and things like that. But that's not much of an issue. So right now I've opened the Selenium browser. So I can do driver.get, and apparently that will open the things. You can see it open it now. Just make this smaller. I can open Google, www.google.com, google.com, and if I run this, it will go to Google. So like Selenium is a really cool thing to do for automating these tasks. So because could you try doing opening Wikipedia using Selenium? So that's not too difficult, because if you look, if you open Wikipedia, control Wikipedia Mars. The thing is, in Wikipedia, what's that thing called? It's very intuitive. So if you want to Google something specific, you can just put that thing after that. So I can say a int is equal to marks. I hope the command here made sense. Essentially, all I did is I made an f string with the input. That's it. So if I run this, it opens that. If int is equal to earth, it opens that. So you can easily see how powerful things are. So I can, if input is nptel, if input is nptel, I get the Wikipedia page of nptel by just running that. So you can see how this is very powerful. In fact, if you know a little bit of HTML and CSS, which is what these sites are made out of, you can selectively copy, and just get all the information from the site itself. For example, here, yeah. So you can use find element to find specific elements in the page. So if you know a little bit of HTML, you can see all of these elements have names. The ID here is history. The name, so this section does not have a name. This section will probably be something like title or something. Yeah, class title. It's also called first heading and things like that. Yes, if you know well enough about HTML and CSS, you can use this for sentiment analysis. This is why I thought I'll introduce this for today's class, because you can use this for the week 8 concepts. So you can, but unfortunately that requires a bit of knowing what what HTML is and how HTML puts things in the page, because to understand how the find element works, you need to know what class name, tag names, and IDs are. And learning a little bit of HTML, it's not difficult, but it takes time, unfortunately. And I'm not they have not told. I'm not sure if I'm allowed to do this. So if you can read the documentation, it is very intuitive. So here you can see that if I want to locate by ID, this is how an HTML page looks like. You can see how it's essentially what I've written here. You can also see it here. So if I click view page source, it will tell me how it looks like. It looks very complicated, but remember that this is not for humans to read, it's for computers to read. So they realize that this is the best way for computers to show information like this. So Where did my scroll bar go? Okay, like essentially, where, yeah, anyway, my point is there'll be many of the tags will have an ID associated with them. So you can see here this div has an ID called simple search. That's, I don't know where it is, but it will be somewhere. That span has no ID. Yeah, this div has an ID of FRB inline, whatever that means. So if you do things like this, you can get the element from the div things and so on. So so driver dot find element by ID. So this has found that element. I'll just save it to a variable. A is equal to, and now since I found that thing, how am I supposed to get the, I should have properly just done this in VS Code. Okay, so okay, okay. So that works. That worked well. Now, Oh, this time it's called FRB message. Okay. Oh, this time the class is FRB message. Oops. Ah, it has found the thing. So a dot. So now I'm able to get the text. The text says Wikipedia is not for sale. A personal message, and you can clearly see everything that's written here is properly written here as well now. So you can use this for sentiment analysis. I am very sorry for today's class being a little more intensive than I thought. I should have not you done the question on Connect 4, but since I'm going to be uploading the code for Connect 4, feel free to look at it and stuff like that. So if there are any questions, feel free to ask. Like we can wind down the class now. I think I've covered everything I had wanted to in the class. You have trouble opening files in Spider. What do you mean? Okay, I I actually understood what you mean by that. So essentially, okay, when you open Spider, okay, when you open Spider, the thing is you must make sure this you're in the right directory here. So if you're not in the right directory here, you will not be able to open the correct file. So let's go to, so now I'm in this folder. I'll just open, so I can open this here, I can run this here. So this that now if I, yeah, the text file should be in that folder. You must make sure the text file is in the folder that you're working in. Otherwise you have to do things like relative files and things like that, which can get confusing. So I've forgotten how to open files. So we, no, okay. Everything's a disaster. Yeah, but you get the point. Yeah. Yeah, it works. On the other hand, if that file was in a different folder, it will just not work. Once again, if there are any, okay, just ignore that I did today's class. Today's class was a disaster. I recognize that. But the my previous classes, could you give a performance review based on, like, scan the QR and yeah. I do not know the exam paper pattern. Like, we are not told about how the exam paper will be, so I cannot help with that. If you want to know the exam paper pattern, I think it'll be better if you check the discussion forum for the NPTEL course. Like, there are essentially two sets of teaching assistants for the course. One set is like us four who will be taking weekly problem solving sessions, and the other set of TAs are the ones involved in answering the questions in the discussion forum. The code is now uploaded, so if you want, play with it. I hope all of you do know when the all the code is uploaded, right? Essentially, today's class, even though it's kind of a disaster, it kind of shows you that even if you know things in programming, you will still get stumped at very small issues. Like, so if you go to the Swime portal, all the way in the bottom, there'll be the problem solving session. If you click that, you can click this and get all the files. So for me, I forgot to copy paste the file things, but so I am Naveen, just in case I didn't mention it out. So I can click my this thing and you. Oh, anyway, so if you go to my this what's that thing called, my GitHub account, you can get all these things. So my files are there on this website. So essentially, the step is go here and go to all these places. Meanwhile, I will update the links correctly. Okay, so it's 8 o'clock. So for the YouTube audience, the class is over. I hope you had a good class, and I'll see you guys next week.